The gateway arch. In this project, we will be finding the equation of the gateway arch in St. Louis, Missouri. After that, you will find another quadratic curve in nature or another arch type thing and write the equation of that on your own. Okay, first of all, this is the gateway arch. It's in St. Louis, Missouri. If you haven't seen it before, it's just a large arch. You can go up in it, and it's approximately quadratic. If you watched this history video that was supposed to come before this video, you'll know that it's actually a catenary curve. So this curve is what you would make if you hold a chain on either end and you let the chain hang between where you're holding it. So it's not quite quadratic, it's actually a hyperbolic cosine equation seen above, but for what we're doing today, we're just going to consider it approximately quadratic. Okay. With this packet, I'm going to go through with you how to find the equation of the arch, and then after that, you'll do one on your own. So the first thing we need to note is that the gateway arch is 630 feet high and 630 feet wide, as noted in this picture. So we need to first find 3 points of our arch. So first of all, we're going to need to put down an x and a y axis. We could put x and y axis through the middle, or we could put it on this side. I'm going to choose to put mine on this side. So here's my y-axis, here's my x-axis. Okay, so the 3 points that we can see on our arch, this one right here is the point 0, 0. It's at the origin. This point right here is the point 630, comma 0. I get 630 because this length right here is labeled as 630. And then this point up here, the vertex, is the point 315, comma 630. I get this point because the height is 630, and halfway between 0 and 630, p plus q divided by 2 would be 315. Okay, on this next page we're going to write the equation in vertex form. Notice I've changed the directions of this problem a little bit. So, let me rewrite my points that I had from the other page. 0, 0, 315, 630. This was my vertex. Remember, I'm going to label that H and K. And then I also had the point 630, comma 0. Okay, to write the equation in vertex form, I only need my vertex and 1 point. I'm going to use 0, 0 because it seems to be easier than 630, comma 0. So I have my x and y. I'm going to have y equals a times x minus h squared plus k. So 0 equals a times x minus h squared plus k. Subtract the 630 over. Negative 315 squared is 99,225. Now if we divide both sides by 99,225, we're going to get a equals negative 2 over 315. Don't forget that these A values, whenever we're finding them in real life problems, are not always going to be nice numbers. Don't make it a decimal. I want you to leave it as a fraction. If you have a question about that on your project, make sure you ask me, because sometimes it won't quite let you leave it as a fraction. So make sure you ask me about that if you need to. Okay, our final equation for the arch is y equals negative 2 over 315 times x minus 315 squared plus 630. Sorry, I kind of ran off the page there. Okay, a couple of questions that we need to answer about the arch. Number 4, given a parabolic curve, what information do you need to find its equation? So this is going to have 2 possible answers. So think about what points you need for vertex form and what points you need if you were going to use intercept form. For 5, we're talking about why does it make sense that a is negative. So in this last problem, my a was negative 2 over 315. Think about what a negative does out front, what transformation it does to your graph, and think about if it wasn't there what the arch would look like in real life. Number 6, if the arch were shorter and wider, how would your value for A change? So remember, A is all about the stretch and compress. So if we made it shorter and wider, tell me if A would be a bigger number, a smaller number. Give me an example of A if that's easier. Okay, so now about your project. You're going to construct your own arch on a separate piece of paper or poster board. Create your own arch. Be sure to include scenery. So I don't want to just see an arch like this. I want to see you design an arch, put scenery around it, something. Scenery also needs to be to scale. So if your arch is 200 feet tall, I should not see a person standing next to it like this, who's also 200 feet tall. Make sure you write the name of your arch at the top of the paper, so make sure you call your arch something. Be creative and appropriate. Label your height and width of your arch, just like the front of this packet had. Find the equation in vertex form, not standard form, but vertex form, and write it on your poster, so make sure your equation is showing. I don't want to see your work for your equation on the front of the poster because I want it to be clean. All of your work is going to go on the next page in your packet where it says put your work here for your equation. So make sure I have that work so that I can check your equation. Make sure you're neat with your work so that I can read it. There will be extra credit given for creative and colorful arches. So if you go above and beyond just drawing an arch on a sheet of paper, if you make a model of an arch, if you do anything like that, that's what would constitute extra credit. You can also be creative with this. It doesn't have to be an arch. You could also use anywhere that you see a quadratic curve in nature, you could use that. You can get creative with it, Google it, see if you can find some different curves that you could use. So here's our grading rubric. Make sure you read through this. Notice that I've changed it. I took out one row and now it's only out of 25 points. Your due date is Monday, October 10th. Make sure you write that on here. And I'm subtracting 5 points for every day that it's late. So do not let this project be late because that's a lot of points to subtract each day. So now for the rest of the class period, I want you researching curves. Find an arch. Find something that's approximately a quadratic curve. Things that are not quadratic curve would be like the clock. The clock is a circle. That's not quadratic. So make sure you're not choosing something that's a circle. When I am back on Friday, we will go over what you've picked, and potentially you could even have your equation done by then and be able to just work on your poster all day Friday. On Friday, make sure that you bring poster board, markers, something to make the model out of. Whatever you plan to do, make sure you bring supplies so that you can actually work on that in class and not have to do it this weekend. Any questions at all, make sure that you email me today with your questions so that I can answer them.